So C, find the equation of the curve. What are we given? We're given the differentiation of the curve. So to find the curve equation, we know we just have to integrate. So integrate it, you get your plus C. You have to find out what plus C is, but we know the coordinate of a point on the curve, and that's a negative 15. However, we know A is 4, so 4 negative 15. Substitute it in, find C, substitute C for 1, and just rewrite the equation again. D, find the coordinates of any other stationary points on the curve. So you know that you already have 1, and that's just 1. That's 4 negative 15. But again, stationary point occurs when dy over dx equals to 0. So just equate the equation to 0, and you're going to get x minus 1, x minus 4. So we know already that x minus 4 is a stationary point, but we didn't know the other one. So we only need x equals to 1. And substitute it into the equation that you found earlier to get the y value, and get 112. So for question 12, we are asked to find the equation of circle P. This, again, is very easy. Just need to remember your equation of a circle. So over here, you're substituting your x and y value, and then over here is your radius. So they've given us the radius of the circle P, which is 10. And we're given the center. Great, makes life easy. Oh, sorry, this part, this x and y value is the coordinate of your center. It cannot be a random point on the curve, it has to be your center. And this is your radius, okay? So that's what I did. Substitute x equals 0, y equals 2, and then my radius as 10, and I just simplified it out. Find the equation of the tangent to the circle P at A. So we know that the tangent to the circle at the point A with coordinates 6, 10. So A is a tangent, right? A is the point where there's a tangent to a curve. And we know A is at 6, 10. So the gradient of normal at A is found by y1 minus y2 minus y1 over x2 minus x1. Why am I finding that? So I want to find the equation of the tangent to the circle, but I don't know what the gradient of the tangent to the circle is. And you see, I have no way of finding that out unless I find the gradient of my normal. So this is your tangent, right? And this is your normal. This is 90 degrees. And I can only find my gradient of my tangent if I find the gradient of my normal, and I use that equation that I spoke of earlier, mn equals to negative 1 over mt, which is gradient of tangent, gradient of normal. So how do I find the gradient of the normal? I use that y2 minus y1 equation, and I already know my two coordinates I'm going to use for that. I'm going to use the coordinates of my A, and I'm going to use the coordinates of the center of the circle. So that's what I did. Found the gradient of normal. From there I found the gradient of tangent. And then to find the equation of the tangent, from there it's just easy. You have your A coordinates, you sub it in, you find the equation of the circle. Equation of the tangent. Find the equation of circle Q and hence verify that the y coordinates of both of the points of intersection of the two circles are 11. So first, focus on what they're asking in the first part of the question. Find the equation of circle Q. So what is circle Q? So, second circle Q with center at the point where this tangent meets the y-axis and with radius. Okay, we know the radius, 5 over 2 times square root 5, and we know that the center is where the tangent meets the y-axis. We found the equation of the tangent, and to find the center of Q, we need to find where it meets the y-axis. That is where x is equal to 0. So I use the equation that we found earlier. Sub x equals to 0, and you get y equals to 29/2. So now we have to find the equation of circle Q. Pretty easy now that we know the center. Remember what I said earlier? This part is your center. So substitute 0 and 29/2 over here, and then your radius is just 5/2 square root of 5 square. That's what I did over here. Then you get your equation of circle Q. So now we have to verify that the y-coordinates of both the points of intersection of the two circles are 11. So what they want is this part. Okay, we have to make sure that both of them are 11. How do you do that? Well, you could just sub in y equals 11 into equation P and equation Q. Okay, and if they get the same answer, which they do, you've already proven that both of them intersect at 11. So find the coordinates of the point of intersection of the tangent and circle Q, giving the answers in insert form. So I've written down the equation of tangent and equation of Q, so we don't need to keep scrolling up and down. And what you want to do is intersect, right? So you have to equate them both together. I just substituted the tangent equation into the y value here and calculated x. And from there, just substitute x back into the y equation to find y, and then you get your two coordinates. That's it. If you have any other requests for any other paper, do comment them down. I can do chemistry, biology, and mathematics papers.